Welcome back to another lesson with Learn Math by Example at Samsung. Imagine you're a mission controller. A deep space probe has just sent back two critical pieces of data. First, the estimated mass of a newly discovered exoplanet, a staggering 7 septillion 340 sextillion kilograms. That's a 7 followed by a 3, a 4, and 22 zeros. At the same time, it's analyzed a single atmospheric particle with a mass of 0.2500215 kilograms. Your mission is to figure out how many of these tiny particles it would take to equal the mass of the entire planet. Typing these numbers into a calculator is a nightmare. There must be a better, more scientific way. This is where scientific notation comes in. It's the universal language for expressing enormous or minuscule values concisely. Every number in scientific notation follows the same format, a times 10 to the power of k. The first part, a, is called the coefficient. The crucial rule for a is that its absolute value must be greater than or equal to 1, but less than 10. The second part is a power of 10, where k, the exponent, is an integer, meaning it can be positive, negative, or 0. A positive exponent tells us we're dealing with a large number, while a negative exponent signals a very small one. Let's apply this to our exoplanet's mass. We start with our giant number 7 septillion 340 sextillion. The decimal point is hiding at the very end. Our goal is to move this decimal point to a new position so that only one non-zero digit is before the decimal point, in this case the 7. Let's count the jumps. 1, 2, 3, all the way to 24 places. Because we moved the decimal point to the left to make the number smaller, our exponent k will be positive 24. So our huge mass becomes the much more manageable 7.34 times 10 to the power of 24. Now for the tiny particle, we have 0 point, a lot of zeros, 215. This time the number is smaller than 1, so we move the decimal point to the right. Again, we want to place it just after the first non-zero digit, which is the 2. Let's count the jumps to the right. 1, 2, 3, and we find it moves 26 places. Because we move to the right to make the number bigger, our exponent k must be negative 26. This gives us the final form 2.15 times 10 to the power of negative 26. Now we can solve our mission. We need to divide the planet's mass by the particle's mass. In your AB exams, this is a key skill. The rule for division is simple: divide the coefficients and subtract the exponents. First, we divide 7.34 by 2.15. Our calculator gives us about 3.413. Next, we handle the powers of 10. We have 10 to the power of 24 divided by 10 to the power of negative 26. Using our exponent laws, we subtract the exponents. That's 24 minus negative 26, which becomes 24 p less 26, giving us 50. Putting it all together, we get our answer, less. It would take approximately 3.41 times 10 to the power of 50 particles to equal the mass of the planet. Mystery solved! While multiplication and division are straightforward, addition and subtraction have one extra critical rule. You can only add or subtract numbers in scientific notation if their exponents are the same. For example, let's add 4.5 times 10 to the power of 5 and 3.2 times 10 to the power of 4. We can't add them directly because the exponents 5 and 4 are different. We need to convert one of them to the other. Let's change 10 to the power of 4 into 10 to the power of 5. To do this, we make the exponent larger by 1, so we must make the coefficient smaller by a factor of 10, moving the decimal one place to the left. 3.2 becomes 0.32. Now our problem is 4.5 times 10 to the power of 5 plus 0.32 times 10 to the power of 5. We can add the coefficients 4.5 plus 0.32, which is 4.82, and we keep the exponent the same. The result is 4.8, 2 times 10 to the power of 5. So let's recap. Scientific notation is a powerful method to write very large and very small numbers using the form a times 10 to the power of k. For large numbers, k is positive. For small numbers, k is negative. When multiplying or dividing, handle the coefficients and exponents separately. And for adding or subtracting, always remember to make the exponents match first. Now, it's your turn. A light year is the distance light travels in 1 year. Using the values on screen, calculate the length of 1 light year in meters. Pause the video now and give it a try.
9, 8, 7, 6, 5, 4, 3, 2, 1.
The answer is 9.45 times 10 to the power of 15 meters. Great work today! For more IB math content and practice problems, visit our website. The link is in the description below, and don't forget to like, share, and subscribe to our channel to get notified with new lessons. We'll see you in the next lesson.